Properties of alcohols. Reactions of alcohols are largely determined by the hydroxyl groups present in the alcohols, and alcohols reacts both as nucleophiles and electrophiles. There are three types of reactions taking place in case of alcohols. First one, alcohols acts as nucleophiles. Alcohols acts as nucleophiles. Okay. Here the bond between OH is broken. Bond between OH is broken. So first alcohol reacts with a carbocation like this. Okay. In the next step, H plus ion will be removed and the product will be like this. Okay, this is the first case in which alcohol acts as nucleophile. Second case is alcohols acts as electrophiles. Here the bond between CO is broken. CO is broken. Okay. So first what will happen? Alcohol reacts with H plus ion and form protonated alcohol. RCH2OH reacts with H plus and form OH2 plus. Okay, OH2 plus will be formed. Next, in the next step, it reacts with Br minus, that is halide ion, and H2O will be removed. Okay, Br minus reacts like this, OH2 plus. Okay, Br minus will come and attack C, and the product obtained will be plus H2. This will be the product. So in this case, alcohols acts as electrophiles. Okay. Next case, the third type of reaction in which both alkyl part and hydroxyl part are involved in the reaction. Okay. Reactions involving both alkyl and hydroxyl part. These are the three types of chemical reactions takes place in alcohols. Discuss one by one. First case, reactions involving cleavage of OH bond. Reactions involving cleavage of OH bond. Okay. Cleavage of OH bond. Here the acidity of reactions of different alcohols, acidity of the alcohols, because the OH bond H plus is removing. So that means acidity of alcohols are determined by these reactions. Okay. First case, reaction with active metals. Reaction with active metals. Reaction with active metals. Reaction with active metals like sodium, potassium and aluminium. Okay, alcohol reacts with sodium, potassium and aluminium and form alkoxides and hydrogen. Okay, alkoxides and hydrogen will be obtained. This is the first reaction. Okay, reaction will be like this: 2ROH plus 2Na. Okay, gives an alkoxide will be obtained, 2RONA plus H2. This will be the reaction. In this case, let us take one example. 6CH3 OH. An alcohol, tertiary alcohol, on reaction with aluminium, the product obtained will be like this. CH3, okay. Thrice Al, okay. This will be the plus hydrogen will be obtained by product. Okay, this is an example for this reaction in which a tertiary alcohol on reaction with aluminium and form this product, and alkoxide will be obtained. Okay, this reaction shows that alcohols are acidic in nature. Alcohols are acidic in nature. Okay, because in this case the hydrogen OH bond is break and H is removed, hydrogen gas is obtained. So alcohols are acidic in nature. So we can say that alcohols are Bronsted acids. Alcohols are Bronsted acids. Okay, alcohols are Bronsted acids. That means alcohols can donate a proton to a strong base. Okay, because it is a Bronsted acid. So when it reacts with a base, okay, alcohol ROH, when it reacts with a base, this acts as an acid. Okay, and what will happen? Product obtained RO minus. So this will be the base. Okay, acid. Here alcohol acts as an acid and this is conjugate acid and this is conjugate base. Okay. So like this reaction takes place. So base, on reaction with a base, it acts as an acid. Okay, and alkoxide will be obtained. Okay, so in such reactions, reaction with active metals, alcohols acts as acids. Next, acidic nature of alcohols is due to the presence of acidic nature of alcohols is due to the presence of polar OH bond. Okay, it's due to polar OH bond. Okay, if electron releasing group like alkyl groups, if electron releasing group is present, what will happen? Group is present, they release electrons. So electron density of oxygen increases. Electron density of oxygen increases. Okay, so what will happen? Polarity decreases. Polarity of OH bond decreases. Okay. As a result, acidic strength decreases. Okay. Acidic strength decreases. So this will be in the case if alkyl groups are present in the OH bond. Okay, if alkyl groups are attached to the OH bond, if more and more alkyl groups are present, the acidic nature decreases. So order of alcohols will be like this: RCH2OH. Okay, primary will be more acidic than secondary, which is more acidic than tertiary. Okay, this will be the order of alcohols. Okay, acidic nature, according to the acidic nature, order of alcohols will be like this. Reaction with water, alcohols acts as base. Okay, here alcohol, this part, it acts as base on reaction with water. Here water acts as acid and alcohol acts as base. So ROH plus OH minus will be obtained. Okay, this is conjugate acid, conjugate base. Okay. Here, as this alcohol acts as base, which shows that alcohols are weak acids than water. Okay, than H2O. Okay. So, in here we can see that H2O is a strong proton donor. It donates its proton, and this alcohols acts as proton acceptor. Okay, it acts as a strong base, and it is a stronger base than sodium hydroxide. Okay, stronger base than sodium hydroxide. Alcohol is even stronger base than sodium hydroxide. So here we can see that alcohols acts as Bronsted base. Bronsted base. Okay, this is due to the presence of these electrons, the unshared pairs of electrons present in the alcohols. Here unshared pairs of electrons are present in case of alcohol, in oxygen in the case of alcohols. So, as a result of this, alcohols acts as Bronsted bases. Okay. Next reaction in this is esterification. Formation of esters from alcohols. Esterification reactions. Formation of ester from alcohols. Okay. Alcohols reacts with acids, acid halides, then acid anhydrides, etc., and form esters. Okay. So reacts with all these acids, acid halides, and acid anhydrides and form esters. First one, alcohol on reaction with acid. This is a reversible reaction in presence of a acid, like concentrated, few drops of concentrated acid is used here. So the product obtained will be RCO will be obtained. Okay. Plus H2. So H2 will be obtained. Okay. For example, CH3COOH plus C2H5OH. Presence of acid, reaction takes place. CH3COO, C2H5 plus H2O will be obtained. It's with acid. Okay. Next, on reaction with acid anhydride. Acid anhydride. R dash CO twice O, acid anhydride. Presence of acid, the reaction, concentrated acid, sulfuric acid. Here the presence of concentrated sulfuric acid, few drops of concentrated sulfuric acid is used, and an ester is obtained. RCOO R dash plus R dash COOH will be obtained. Next, on reaction with acid halide, ROH plus R dash COCl, acetyl chloride. Here a base pyridine is used. Okay. Product obtained will be COR ester, RCOO R dash and HCl. Okay. These are the different reactions for the production of ester. Okay. In this case, this is a reversible reaction. So, if we are not removing water, so as soon as the product obtained, we have to remove the water. Otherwise, reversible reaction takes place. Okay. Next, in this case, acid chloride, we are using a base pyridine. So, what will happen? HCl gets neutralized in the presence of pyridine. So, we will get the product. Otherwise, backward reaction takes place. Okay. So, the reaction in which acetyl chloride is used and form ester, such reactions are called as acetylation reaction. Okay. Acetylation reaction. And the ease of esterification is in the order. There is an order for different alcohols for the ease of esterification. Ease of esterification. Okay. How easier the esterification takes place. Ease of esterification. In such a case, the order will be primary will be more easier than secondary, which will be more easier than tertiary. So esters are easily obtained in the case of primary alcohols than secondary, which will be more easier than tertiary. This much about the esterification reactions.